3,
But that's just
4, that is 310, 275, 179, 632, 321. Once your once your bit question is identified, you have to divide the array into lower bound to mid position is one sub array. Next mid place 1 2. Mid place 1 2. Upper bound is 1 sub. This is lower bound and this is up to mid. Next one from mid place 1. Mid place 1 2. What is mid 4? Mid place 1 5. 6 7 8 9. This is called upper bound. So first element is 4 of T. It is 3, 30, 5. Go for this first pattern. If this is a new subarray, then if it is considered a new subarray, A1. So this is now it is upper bound with respect to this A1. And 0 place mid position you are again calculate. 0 place 4 by 2, that is 2. So next part is up to note down parallelly 0, 1 up to 2. 30 note of 117. 2 place 1, that is 3. And also last. Then this is lower bound. It is actually made that is true. But with respect to array A 1 2, that is A 1 1. 0 and this is 2. Again, in final by this is equals to 0 plus 2 by 2 is 1. This is 1, 310, mid place 1, minus 1, that is 2. And total of the costs, we go to 275, 179. Still they are the let's say this is 4. Last will you are done, sir. Legal है ना statement ना अगर तो मुझे this you guys up to probably we should have also. So algorithm open second part of the algorithm followed by match. They have LB comma mid comma UV. The algorithm last session of last three. Match part second part of the you open that second part. This is I right. This is mid. This is actually upper bound. The lemon is variables of L is equals to I is equals to lower bound, J equals to mid place one, and K equals to LB. So this is a mid value. This you can say upper bound, or you can say mid place one or mid place one. So LB is equals to I value, right? I is equals to LB, sorry, I is equals to LB, and J is equals to mid place one. Mid place one. So 3. Compare A of 5 greater or equals to A of 2. This time there is a condition. Why look? What is there is a condition? What is there in the condition? I less than or equals to mid. Also, J less than or equals to upper bound in upper bound. If these two conditions satisfied, then we have to check if condition. I mid color mid position is 1. What is I is pointing to position number 3. The 0 less than 1. But also J less than or equals to upper bound. J value mid place 1. Upper bound also 2. 2 less than or equals to 2 equals to 2. Both the conditions satisfied. Then compare A of I to A of J. A of I is the first value of the first value. A of J is nothing but mid place 1. Mid place 1 indicated second value of first element. Second value of first element. Because you have partition array each time, because lower bound to mid first array, second array from mid place 1 to upper bound. So if it is only one element, unfortunately, mid place 1 come upper bound both it is same. So mid place 1 indicator represents second part of first element. I represent first part of first element. This is 310, this is 170. A of 5, 310, less than or equals to 170. Is true or false? 310 less than or equals to 110. Huh? True or false? If it is false, come to else block. In else block, what is the statement? B of K is equals to A of J. It means that 310 is less than 179. 310 becomes the lower value. 310 the first element. In the new subarray. In the new subarray, that is B. A is so here 370 is less than 179. A of true is A of I better. So if it is false, A of J, we need to place in B of K. What is A of J? Is 179. 179 will become temporary array first element. Right, 179. No, J is incremented by 1. J is 2 now, as of now. J becomes 3. Just hold it. J equals to 3. And we also incremented means once it is 1, now it is 3 pointing to this solution. That is 2. Okay, next value we place the value. Right. Again, repeat this loop until this condition fails. Again, I less than or equals to 3. Still I is pointing to 0 only. 0 less than or equals to 1. This is the equation. True. And also J, that upper one is a 2 only. Is 3 less than or equals to 2? No. If this condition falls, don't compare this element with this one. Exit from this while loop. While loop goes there is a statement called if I greater than B. There is a statement after exit the while loop. If I greater than B. If I greater than beta, greater than equal, greater than beta, we do something. But here, what is I value? 0. 0 greater than beta. 0 greater than no. If this condition also false, again it is what? S club. S club level. What is S club? Why? S club, sorry. This is in S club. Why? I less than or equals to I less than or equals to U. Now, if this condition false, whether it is true. I is still it is less than or equals to. In such a case, in the new way of A, place A of okay. So A of I, that is not A of J. There is no this A of I. There is no A of I is placed in B of K. What is A of I pointing? 3 tables. Right? 3 tables need to place it here. But here, make sure that before is 7, 3, 10 and 270. It should be a sorted order. That is a sorted order. So here, unfortunately, what is there in first part? 375 and 2, 3, sorry, 310, 275. This must be a sorted order. But which is not sorted order. Before going to start, there must be a sorted order. To view sorted order, again you have to divide it. Actually, first is there 275. We need to sort out here. If it is sorted out, then definitely it will be combined as 275. 275 followed by 310. Is it? So, the 275 by and 310 can be compared with 179. So, same process can be applied by starting these two elements and repeat this step until each these three elements are sorted, for example. So 3, 0, 1, 2. These three elements are sorted. Now you go with these two. Sort out it individually. Then compare these three in order. Result it. Which is the result. 1, 2, with 3 sum of 4 positions. And 0 compared to 3, 0 compared to 4, and so on. It is compared. So now we get a array 0 to 4. Or 0 to 4, 5 elements are sorted order. So that's what I said. Divide and conquer below. First method divide. Next conquer. Conquer the recursively solve the solution. Same solution recursively we are calling for each subarray comparison. Comparison strategy. Then we have to finally first position will be first part. This to be started. The same will go for the second half. We get these elements again from 4 to 9 in started. Now compare these first 4, first 5 with the last 5 again one by one. We get one unique solution 0 to 9 are the sorted order. So that is the major start which already we have defined. So general procedure, but there is you have forgotten to write major procedure, right? So this is about major start. Then we move on to the next application of divide and conquer. What is the next application of divide and conquer? Quick sort. Second application. Quick sort application. The quick sort that is sort out an algorithm. So these are the different, let us assume that these are the different persons are there in the class. These representations of height as compared to this is very short, 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 compared to these two is very short, like that. Right? Like in the classroom, there are different kind of students are there. And when continuum class, so like not class, assembly, no, PT sir interested. The PT sir is told that everyone should make a line with height provision. So great solution. How the students themselves will stand the line as per the height. Is the one way. Students themselves should take a decision. Otherwise, the PT sir will come to everyone and ask them to stand. Your place is this one. You stand behind him. You stand behind him. That is the procedure. Right? Instead of these two, it is a better solution. Students themselves to understand by their height and they have to stand in the line. Easier. Sir, major for this question. So, but here every student will stay in the according to their heights. Before that, we'll identify one person who is very short in the class. Short in the class. So first, a person who is very short in the class will stand in the front. With respect to him only, next person. With respect to him, next person. With respect to him, next person. With respect to him, next person. Okay. So here to make that, first of all, the sir duty is to identify the first person who is very short in the class. What is the portal all of us tried? Other first, you need to identify one person with respect to the others. Again, ask them to stand next to back. So this procedure will be very fast. So it sort also will be very fast starting like that. But it is not like fast we can say as compared to maybe sort the name itself is sort no very fast. So that statement is not good. So very in the Pixar general procedure, we are going to identify one person. This is most important. In the list of elements also, from the array of list of elements, among set of elements from the array, it is randomly you choose a one element. That's most important. So here also in the classroom, the sir need to identify one person, either very tall, either very short, either average height. So if the PD sir is identified a person who is very height person with that, then ask them to sit, ask them to stand last. Then the next height means right, otherwise, you are identified as who is the moderate height. So ask them to sit in the middle. With respect to him, everybody who is very taller than this person, then ask them to sit backside. Who is very short, with respect to this person, ask them to stand in front of him. There are three cases. That three cases will be depends upon the identification of the person. The first identify as a person very short ఉంటే మన ఫస్ట్ ముందు నుంచి పెట్టి మిగతా అందరూ పట్టుకుంటారు పైన మీరు ఐడెంటిఫైడ్ అయితే వెరీ హైట్ పర్సన్ ఐడెంటిఫై చేసాం అనుకోండి క్రైటీరియా ఏంటి సో సో నెక్స్ట్ వచ్చే వాళ్ళు వీటిని కొంచెం సో అదర్వైజ్ మోడరేట్ హైట్ ఐడెంటిఫై చేసాం సో మధ్య నుంచి పెట్టి విత్ రెస్పెక్ట్ వి కంపేర్ you are supposed to stand beside him because you are taller than. Next. Three criteria, three situations. And here also in the list of elements in the fixed order. List of elements in the fixed order. Right? Identify any number usually. Consider as a first element, as a last element. What is this name? Pivot element. Consider this pivot element. First, we will decide that pivot element position. I have identified a very short person like that. Then I will decide the position. So you are very short among these students, so you come here. Then I'll call next, whatever the position is. Once you set a position, then going to change remaining. If you have identified this element as pivot, first where this element will be the list. The new list, fix that position. The fourth element position may be a third element. So accordingly, there is a procedure. Based on the procedure, you fix the position of fourth. Then, with respect to this, all elements to the left side is less value, all elements to the right side is greater than this value. Then automatically, final list will become the sorted element. Huh? So this is if it is identified itself the longest element, then fix the positions, the element positions, then remaining elements to the left is lowest elements, and to the right no more elements because your identified pivot element itself is the longest element, larger value in the given list. The తర్వాత ఏముందో because last ఏంటంటే identification కాబట్టి list of elements left over before this 10 only. Right? So that is the general procedure of quicksort. We'll just note down this one. Yeah, before we start Melisot also, and there is a possibility to ask in the academic hearing, or the question may becomes, what is Melisot, right? Melisot algorithm. Or consider the list of elements, apply Melisot technique, and write an algorithm with an example. And also, what is Melisot algorithm? Derive the time complexity of Melisot. What is the time complexity of Melisot? Time complexity normally you can say by time square. You can say n log n. We can say order of log n. We can say order of n. Only if they ask the time complexity can we can say order of so and so. So how if it is order of n square, how it is order of n log n, or how it is log n, how it is. If your answer is order of n log n, how it will be? They are asking that not only the time complexity of method derived time complexity of method. So we need to show that how it will be that n log n. So before we discuss method, write down time complexity of method. Time complexity of method. Write down. Let T of n. Let T of n complexity of method. Let T of n be the time complexity of method. Time complexity of the method, then the recurrence relation method will be, then the recurrence relation for the method will be, the recurrence relation for the method will be, here, then the recurrence relation for the method will be written as, here 1 is equals to 1, here 1 is equals to 1, when n is equals to 1, when n is equals to 1. Otherwise, otherwise, T of n is equals to, otherwise, T of n is equals to 2 into T of n by 2 plus C into n. Today, C is a constant. C is a constant. Where C is a constant. And V, where V becomes 2 power k. As we know already, divide and conquer approach, we already solved the recurrence relation. Then let's say this is an equation first. Then what is T of n by 2? Say, substitute n is equals to n by 2 in equation 1. Then we'll get T of n by 2 is equals to 2 into T of n by 2 plus C into n by 2. This is equation 2. Substitute n equal to n by 4 in equation 1. T of n by 2 is equals to 2 into n by 4 by 2 plus C into n by 4. Now substitute equation 2 in 1. Equation 2 in equation 1. What is equation 1? That is T of n is equals to 2 into T of n by 2. T of n by 2 is there and equation number 2. That is T of n by 4 plus Cn by 2 plus this Cn. And this is equal to 4 Tm n by 4 plus Cn plus Cn. That is 2 Cn. Equation 3 in equation 4. And equation 4 is T of n is equals to 4 into T of n by 2 factor. T of n by 2 value is equation number 3 is already available. Let's choose here from this. Choose here. This is 8 T of n by 8 plus Cn plus 2 Cn, that is 3 Cn. T of n is equal. And this you can write same like 2 power 3 T of n by 2 power t plus 3 C square. And that we can generalize as 2 power k into T of n by 2 power k plus k into C into L. N equals to 2 power k. Apply log function on both sides. Log n is equals to log 2 power k. Then that is equals to k equals to log n base 2. This 2 power k we can write n by n plus k into c into n. This is n into T of 1. C is a constant. right? And n k is what is clear? Log n base. This k of 1 is n into 1 only. C into n log n. So from this k of n is equal to order of CL k of n is equal to only n. So n plus x C into n log n. Higher order term is C into n log n is higher order term. So before C into n log n we should write actually. But C is a constant I don't know. So that's what I need to log n is a time complexity of marks up. Normally, whenever we ask now what is the time complexity of Mixer, we'll say directly n log n. But how n log n will be? Now we'll move on to fixed order. Yes, fixed order. Any one element procedure first will do. Any one element. This is 0 and this is 1. So it's not upper bound. This is I, for example, this is J. J is a pointing to the last element. I is pointing to the first element in the array. Right? So this is pivot element. First we compare A of I value is less than or equals to pivot. There is a condition. Pivot entity. Pivot element is question. So either starting element and last element and usually we go with the first element. So A of I less than or equals to pivot element I think. See here. A of I is 7. Less than or equals to pivot element also 7. If this condition is true, Virendy, Mike. Happy to after some certain to somewhere. So first element compare with pivot element. If this condition satisfied, increment I value. Increment I value. Procedure will get blind. I is incrementing. So I is pointing to this one. Pivot still same. Next, A of I becomes 6. 6 less than or equals to 7. True or false? True. Then again, I increments. 10 less than or equals to 7. False. So don't disturb I till I point to 10. Then compare A of J is greater than 5 volt. Whether A of J is greater than 5 volt. Can we get A of J very element? A of J, listen, A of J is the value, point is the last value. 15 greater than 7. If it is true, J minus minus. Reverse our. J is, now I is pointing over here, stop right. So J is pointing. 1 is greater than 7. No. False. Stop the process. So this is the way we need to decrement it. Now let this condition. We take, so here I from here, J from. Whether I less than R1. What is I? I point 0, 1, 2 by that. 0, 1, 2, 3, 4, 5, 7. So this is I point 2 less than 6. So this condition is true. 8 is condition is. Tell you we need to swap. We need to swap. So same example in the master planning में board पे ड्रा सेट अपन ड्रा से चलो लगा से ड्रा सेट प्लीज देखो. First list of elements find. So we start looking at it. First element pivot and go and initial element other. Initial element pivot करना. With respect to the pivot, the initial element should be initial element is K of I. Should be less. అది satisfy అయ్యేది అవరికి I increment చేయాలి. ఎప్పుడైతే pivot పైన I value greater అయితే stop. Reverse order లో లాస్ట్ నుంచి వచ్చేటప్పుడు pivot కన్నా greater ఉండాలి. For next element greater next greater. Everything shortest element stop. Then both the cases stop. I value stop and J value stop. After stopping, check whether this condition is it if I less than J. Condition satisfy either swap A of I with A of J. Pivot will be swapped epudu E I and J overcross sometimes. Sometimes I and J will be overcrossed. At that moment, swap pivot with A of J. So now A of I and A of J will be swapped. So then the resultant array becomes 7 will be same, 6 will be same. This 10 and 1 will be swapped. Here 1, 5, 9, 2, 10, 15. Pivot I is pointing to this, J is pointing to the I comma J swap. Now repeat the process again. A of I less than 5 volts. A of I is 1 less than or equals to 7. True. I is incrementing. 5 less than or equals to 7. True. I is incrementing. 9 less than or equals to 7. No. Stop. Stop here. J value. A of J. W is 10. 10 is greater than or equals to 7. True. Decrement. 2 is greater than or equals to 7. No. Start. And I greater than J. I is 4. J is not greater than less than. I less than J. S 4 less than 5. 2. Then swap again. A of 5 and A of 8. The array becomes 7, 6 A of I, A of J. Use 2. There are 6, 1, 5, 2, I, 10, 15. This is 5 volt. I is pointing to 0, 1. I is pointing to 4, 1. I is pointing to 0. Now again, A of I less than A of 5 volt. A of I 2. 2 less than equals to 7. True. I increments. 9 less than 9 equals to 7. Stop. No. And come to the other side, G. G, A of J greater than or equal to 5 volt. Is true. And increment. This is when decrement J. That is 2 greater than or equal to 7. False. I was there was a stop. And check the condition. I less than G. I is pointing to this one. This is 5. J is pointing to this one. This is 4. Is it true? No, false. When it is false, come to the extra. There you write down. Swap with 5 volt and you write down. J value. Swap 5 volt comma A of 3. When it is swap, the array becomes so 5 volt with A of J. A of J means J is pointing to J is pointing here. J overcomes no. J becomes 2. This value 2 and 7. So first it is 2, then 6, then 1, then 5. Here it is 7. Here it is 9. Here it is 10. Here it is 15. Whenever a pivot element is swapping with other element, after swapping of that, check this array with respect to the pivot. What is pivot element? Pivot. 7 is the pivot element. Take this array with respect to the pivot. Less than of these all the elements are sorry with respect to this pivot element, left to this all are less values. Whether those are in sorted or unsorted, but 7 can only takku. After this also, there may be a sorted or unsorted, but the elements are greater than this. Yes, 7 is greater than 9, 9 is greater than 7, 10 greater than 7, 15 greater than 7. And also 5 less than 7, 1 less than 7, 6 less than 2 less. But which are not sorted. Then compare this and consider this position has been fixed. Now you consider this 2, 6, 1, 5 is one subarray. Consider one element as pivot element. Again, do the step because the same procedure. Once we fix the second element position, we'll do here. And this is J. This is I. A of I 2 less than or equals to 2. True. Then I is incremented. 6 less than or equal to 2. False. Stop. Then J value 5 greater than or equals to 5 volt 2. Condition 2. J is decrementing. 1 greater than or equals to 2. Stop. What is I value? I less than J. I is pointing to this. This is, for example, this is 0, 1, 2, 3. I is 1 less than or equals to J is 2. Condition 2. Then here swap A of I and A of J. A of I, A of J. So A of I 6 and 1, you have to swap it. That is 2, 1, 6, 5. Still it is 5 volt this one. This is 5 volt only. I is pointing to I is here and J is here. 0, 1, 2, 3. And A of I 1 less than or equals to 2. Condition 2. I is incrementing. This becomes I. 6 less than or equals to 2. No. When J 6 greater than or equals to 2. True. Then I becomes J becomes here. 1 greater than or equals to 2. Then swap with square pivot comma A of G. Pivot is 2, A of J means this 1. So these two are interchanged. So first it is 1, next it is 2, next it is 6, 5. With respect, one pivot element is swapped out. Swap out. Check this array with respect to the pivot. Everything left over less value, greater than greater value. Right side, greater value. But this is only one value, no need to sort. And after this, 6 comma 5, which are not in 6 comma 5 sorted order, and repeat the same step. Repeating the same step, it will be sorted as 5 comma 6. And before this, anyway, it is 1 comma 2 comma 5 comma 6. And in the second part, which is other part, 7, 9, and 15 already sorted out. So final array becomes 1 comma 2 comma 5 comma 6 comma 7 comma 9 10 18. Give you the final. For same thing, we'll write an algorithm. So algorithm రాసే ముందు ఒకసారి theoretical చూసుకోండి. First element is pivot అనుకోండి. If this are an array, first element is pivot and also point into I. Last element is G. Right? First element you compare with pivot. If first element is less than or equals to pivot, first element at a left side, last element right side. Pivot and first element and last element to always compare with pivot. But how would it be? First elements are the left side elements, pivot colors number. A of y less than pivot. Okay? First element is up to next compare, go over this. And this element also should be less than pivot. Yes. Next, go over the next element, less than pivot. No, it is not less than, stop it. Go for the rightmost element, last element. Rightmost element always greater than the pivot. So this A of J greater than pivot. Yes. Again, go for the rightmost term, next right part one. So the last part one, the last part one, the pivot should be greater. Yes. Next last part two should be greater. But unfortunately, no. And I comma J value. రెండు false అయినప్పుడు I will stop somewhere else, J will stop somewhere else. The index of I comma J values, index of I comma J values, they are always greater. That is I less than 3. I कన్నా great value of yes, I is less than 3. Okay? I comma J values, position of the values are I didn't give values sort here. Otherwise, I less than J is not there. I is closer to J. I is greater than the J value. Then pivot element with the last element. Pivot element last element plus J next or not J J into the I. So swap to the pivot element is the A of J value. If we get so whenever pivot element is swapped, then now it is partition. With respect to pivot, first subpart is one subarray. After pivot, one more subarray. That is partition. So partition అయ్యాక చేస్తాం అని కంపారిజన్. Then write an method algorithm. Sure. Fixed. Lower less than that. It means that check whether the array contains more than one elements or not. So brilliant. Partition here. Array into two parts. Low to high. By finding one position. Table 5 volt. So that will be indicated as very clear into the position is my was fourth position working, sixth position working. Okay, part. And next one is apply this third repeatedly. A position is a third algorithm. And second first part is same repeat jar. Again we need to decide a pivot element position. So pick sort of low comma pivot position. That's a moon element. And also second part consider from 5 volt plus 1 to 5. There are two parts. 5 volt extend sixth position lo 1 to 5. First part 6 kaakunda 7 to 10. P minus 1, P plus 1. So this is an extra algorithm, but here in this we are calling a method called as partition. But what will do the partition? In the partition, again we have a comparison. A of 5 with 5 volt and so on. That will define the procedure or that method definition will be separately right here. So it returns some integer value, int of partition of low comma high, or we can say is equals to low, b is equals to high, and while I less than this, do this one. And also here, 5 volt element we are saying, what is 5 volt? We have 0. You can say 5 volt. First element is 5 volt. So we have I, then I equals to 5 equals. I have to repeat this. If this condition is true, then I will be implementing. I will be implementing. Not on this one. If the condition clause we have J greater than 5 volt, greater than 5 volt, then what we do? J will be decrementing. J will be decrement. This while loops will be repeatedly executing till the condition fails. When these two conditions fails, we say if still I less than B or not. If I less than J, first of all, we need to swap. Instead of the A of I and A of J, we need to swap. Else, swap A of J with 5 volt or 5 volt is J. And here, once this explode is quite close, no? This pivot element is swapping with A of J. It means that that position has been fixed. Maybe a fourth or sixth position. Any position, not fourth position, fifth position. So that position is fixed. That position you have to return. Return is P. So where is one of P and last one? Here it is not P. We have J to replace this thing about P. Here not P. We have to write J. A of J is element. J is a position. Return is position and this starts close. One stresses matrix multiplication. Stresses matrix multiplication is on. Which is divided by distance. One thing matrix of the event of first row to matrix multiplication first row of the first matrix element. First matrix the first row. Second row the second matrix of first row. That is why. First matrix of first element multiplied with second matrix of first element. 152. Next, first row, second row of first matrix with second column of second column. And position. So first we do normal precision. General procedure. General procedure. There is a matrix A. Any A plus B, that is equals to C. Yeah. First row, first column. Means A equals remaining you do that. Okay. Remaining three elements. Then what is equal to see a into F plus into F. Next second row, first column. Second row, second column. The second row, first column was a computer. Second row, second column, computer. Already math pattern is practices. And C into E plus D into D. And same second row, second column. C into F plus D into percentage. This is the way we need to do general matrix multiplication. Here, tell me the number of multiplications. Tell me number of multiplications. And also tell me number of multiplications. Number of multiplication in this. And this is what you can say. You can matrix C is C11, C12, C21, C22. What is that? C matrix law. First row first element, first row second element. Second row first element, second row second element. That is the way we need to represent matrix system. Now tell me here how many multiplications we did. Tell me. Right? See, 1, 2, 3, 4, 5, 6, 7, 8. 8 multiplications. 4 additions are equal. Note the number of multiplications is 8 and additions are 4. The elements of matrix A. The elements of matrix A is accessed is equals to. Listen the question. Number of times the elements of matrix A can be accessed. It is also matrix A of elements in access is matrix A of elements in A, B, C, D. A, B, C, D during this computation of C11, C12, C21, C22, it is also access this. Data A, B, C, D only. Here A, here B, 2, 3, 4, 5, 6, 7, 8. Is 8. Right? In the same way, note of this also. Number of times the elements of B. The elements of matrix B can be accessed. B can be accessed. Yes or no? Is it also A? Right? So that 8 can return to 4 3. That is 8 also to 4 3. Therefore, if there is an n by n matrix, there is n by n matrix of A comma B, of A comma B, A comma B. To perform matrix addition between A comma B, between A comma B, to perform matrix multiplication between A comma B, the number of times of the elements, number of times of the elements belongs to matrix A and B, belongs to matrix A and B, will be accessed, belongs to matrix A and B, will be accessed is equals to n power 3 plus n power 3. Adana? N power 3, n power 3. So here we can note this A and B are the 2 by 2 property, 2 power 3, 2 power 3. If it is A comma B n by n matrix, then elements of A can be accessed n power 3 and elements of B can be accessed n power 3. Right? So both elements can be accessed n power 3 plus n power 3. That is equals to 2 n power 3. Therefore, time complexity, therefore, time complexity of general matrix multiplication is time complexity of general matrix multiplication is so And here 2 power n by 2 into n power 3. General matrix multiplication is order of n power 3. 2, I am ignoring the value 2 because as per the rule of constants can be omitted. So we go with what we have. Two constants. We have the provision to remove. Ignore the constants. So general matrix multiplication triangle complex will be order of n power 3. Right? So here we want to discuss Francis matrix multiplication. Why we need to study Francis matrix multiplication? So if I produce a matrix multiplication, so XYZ matrix multiplication is introduced. Why you people should accept? We should accept a new method as the old pattern is as compared to the old one, which is new pattern is easy. Easy with respect to according to this algorithm with respect to time or space. So usually we measure algorithm which is the best algorithm we consider the set of algorithms that exist for the same problem. Among those set of algorithms, one algorithm will be finalized that will be finalized based on the performance checking. Performance with respect to the time, with respect to the space. And also, as we know the matrix multiplication procedure, and somebody is called as process of the produce matrix multiplication procedure. There are two approaches are there. As we know the general procedure, we get the same result of a comma with so to C value. And if you follow this process and introduce a new method, if you follow that also, then we get also same result. Then why should we accept, as we know, earlier this general method, why should we accept the new approach process are introduced? We consider this process practice multiplication procedure when compared to space and time. The performance will be better than the test. If it is performance as the performance of the general procedure, time complexity is order of n power 3. If the person who is introduced procedure for matrix multiplication may be order of n power less than or equals to 3. N power less than or equals to 3 time complexity of that procedure is there, definitely we should accept. Because time is less time consumption is there to complete the matrix multiplication. కాబట్టి మనం యాక్సెప్ట్ చేయాల్సి రైట్ సో the divide and conquer approach. So who is the person license is trying to develop a solution for the matrix multiplication, but he has followed divide and conquer approach. So divide and conquer approach is following that first the complex problem can be divided to sub-problems and repeatedly we divide the sub-problems till the problem is simple as small problem. The same way, the presence is introduced. If it is 4 by 4 or 8 by 8, whatever it is, the matrix size is it. He has divided into first two halves. And we check this sub matrices. If the size is still less than 2 by 2 greater than still greater than 2 by 2 matrix, again it is divided into halves. Again it is divided into halves. Such that every matrix given size of matrix can be divided into two parts until we'll get a each submatrix size is 2 by 2. When you got a 2 by 2 matrix, and for example, there are 4 by 4 matrix. So it is divided into 4 elements, 4 rows, and 4 columns. So this is 4 by 4. This is 4 by 4 matrix. For 4 by 4 matrix, you don't have a solution. He followed divide and conquer approach. He is saying that first given matrix size, you take it the original matrix, and when it is the size of the given matrix is greater than 2 by 2, yes, it is greater than. Then you divide it into Then consider submatrix size. This is first part, second part, third, fourth parts. And consider this size. What is the size of this first part? Huh? This is 2 by 2. And this one also 2 by 2. This one also 2 by 2. This one also 2 by 2. After dividing into two halves, check the submatrix size. If it is still greater than 2 by 2, then again do into two parts. Otherwise, if it is equal to 2 by 2, stop the process. Stop the process. He has developed some formulas. Apply my formulas. Apply, I'm giving some formulas. Apply my formula. Don't do this first column, first column, no equal first column, second column, second column. Don't do that procedure. Addition process. Yes, I will give it plus one set of equations is given. Substitute those equation values of equation. We get final value. We get a final value. He's saying that it's a procedure. And anyway, it is a new procedure. It is a technique is new. But we should accept and it is approved already because he has proved that if you follow my procedure, he has proved that if you follow my procedure, definitely we get a time complexity less than order of n less than 4. It is less than definitely n cube, less than a certain cube. He has proved. Because of that, we need to study this Clausen's matrix multiplication. What is the Clausen's matrix multiplication also? We derive. So normally, Clausen big of n power 2.81 is proved. Clausen's matrix multiplication time complexity is big of 2.81. This is most important. Right? 10 power 2.81. You go up 2.5. What is the formulas we derived? Directly. So next line I don't. Strasson's right. Strasson's try to reduce Strasson's try to reduce the time complexity from reduce the try to reduce the time complexity from big of order of n power 3. N power 3 30 Next line. Try to reduce the time complexity from big of n power 3. Next. To reduce the time complexity, we divide the n by n matrix into n by n matrix into submatrices. N by n matrix into submatrices. N by n matrix into submatrices until we get each part as 2 by 2. Until we get each part as 2 by 2. Until we get each part as 2 by 2. The given matrix size is given matrix size is 8 by 8. This one it will be partitioned as 4 by 4. Again, three partition as 2 by 2, 2 by 2, 2 by 2, 2 by 2. Same way, this. Yes, David. And you take away the negative matrix. First of three. Check, it is 2 by 2. No. Again, divide it. Yes, it is 2 by 2. This 2 by 2 contain normally A, B, C, D. Here, this. So, is the third formulas are these. This is matrix A, matrix B. A into B is. Then one solution C. Likewise, two matrix, two. Individual subsolutions. This is solution, subsolution 1, subsolution 2, subsolution 3, 4, 5, 6, 7, 8. 8 subsolutions. So, according to this, subsolution 1, subsolution 2, match these two as one part. Then these two solutions match it one part. These two solutions one part. Now again, this one and this one part, this one part. Now hold together as final solution is C. So this formula is based on the A, B, C, D, E, F, G elements only. Like PQ are some. A, B, C, D, E, F, G, H are the two by two matrices. A, B, C, D to 1, 2 by 2. E, F, G, H are 1, 2 by 2. Based on these 2 by 2 matrices only, we derived formulas. Next line down. Better. General note on this one also. The matrix A can be represented A11, A12, B sorry, B21, A22, and B is equal to matrix can be divided B11, B12, B21, B2. Then what is the C matrix? Can be represented with a C11, C12, C21, C2. Okay. When you consider this is A, so it is B. And this is again A, this is B. So whatever it is, just based on this values only. When the formula is defined, next time write down. Patterns, formulas. What are the patterns? These are the formulas as fractions are developed. You know the every matrix A11, A12, A21, A22. Like we also. Final matrix is C11, C12, C21, C2. So the final matrix C11, if it is A comma B, that is C now. This indicated C11. This value can be computed. This P plus S minus T plus T. But what is that? P value? P value is the values of given matrix of A comma B. In A matrix, we know what is A11, we know what is A2. And also B11, B2. So apply substitute those values here, we get the P values. Like P, Q, R, S, P values created. Those values we substitute here, P plus S minus T plus T. Then we get the one result value one. C1. So here we are not doing multiplications, more number of multiplications. Right? So if you follow this, definitely we get a matrix multiplication process. See here, let's take one example. Please A equals to, I don't know, note it, sir. Once it is over, right, take one example of a matrix. One, and B is 0, 0, 1, 1. Generally, C is equals to A cross B. Normal procedure, as we know the procedure. What is the value? This 1 into 0, 0, plus 1 into 1. 1. And 1 into 0, plus 1 into 1. 1. 1 into 0, plus 1 into 1. 1 into 0, total value, all 4 minus 1. మనకి ఇదే easy. We are familiar with from childhood. But not for you, it is for the system. Where to write a matrix multiplication program by using conventional method and also write a C program for matrix multiplication by using this formulas. The computation speed is more if you follow this system. And its computation is very fast and computation is very fast. So that's what we should accept. And here, say when the method we follow this formulas. What is P? P is equals to A11 plus A22. What is A11? A11, A12, A21, A22. Likewise, A11, 1 plus A22 also 1. B11 also 1 plus B11 0, B22 1. And this is equals to 2 into 1. So, likewise, find out P, Q, R. ఇప్పుడు ఇవన్నీ చేస్తే పడినారు కాన్సెప్ట్స్. Now tell me Q, R, S, T, U, V values. Tell me what are these values? What is P, Q, R, S? What are those? And P, Q, R, S. Maybe where are the formulas? No. Q? What is the value of Yes. What is the value of this? B one one. A one is zero. That is become zero. R is equals to A one into B one two. Zero minus B two two. It means minus one. S becomes A two two. A two two is one into B two one. One minus B one one. Zero becomes this one. T is equals to A one one plus A one two. One plus B two two. A two one. That is two. U is equals to A two one minus A one into B one zero plus B one two zero. It is zero. B is equals to A one to one minus one. So B two one plus B two one. So it is also zero. Then P one is equals to P plus minus P plus P. P values 2 plus 1 minus P 2 plus P plus 0 to C 1 2 R plus T. R is minus 1, T is plus 2. That is equals to 1. C 2 1. Q plus S. Q is 0 plus 1. That's equals to 1. C 2 2. Huh? C 2 2. P plus P plus R is minus 1 minus Q is 0 plus U 0. Better? This is 1. C22 also. Then resultant schematic values are C11, C12, C21, C22. What is C11 value 1? C21, this is final matrix. As we got same also in general also. It is nothing. If the both the bases are following, the result will be same. Then definitely I can say this is the best algorithm because if you follow this, he's saying that less than n power 3 is a time complexity. That is order of n power 2.81 is a time complexity. It is reduced to perform matrix addition, multiplication between two matrices of size 2 by 2. Then definitely basis matrix multiplication is the best one. And so next one time complexity of basis matrix. Right on. So the recurrence relation. N complexity for basis factor. Under this diagram, after applying Streisand's formulas, after applying Streisand's formulas for matrix multiplication, after applying Streisand's formulas for matrix multiplication, the recurrence relation is defined as P of n is equals to B, that is equals to 7 P of 7 P of n by 2 plus C into n square. Right? When it is n less than or equal to 2 and greater than. Seven into T n by 2 plus C n square. These are the Streisand's formula. PQ is KUV. And C11, C12, C21, C22. All these formulas, how many multiplications are there? How many multiplications are there in Streisand's formulas? P2, V and also C11, C21, C22. Seven multiplications. See here, below, this is one multiplication 1, 2, 3, 4, 5, 6, 7. There are no multiplications here. Total 7 multiplications are there. So that's what the recurrence relation 7 into P of n by 2 plus Cn square some constant into L square is a number of additions. Right? When it is size is greater than. So same recurrence relation here. We don't know this is right like 7 n by 2 plus Cn square equation 1. And we know that what is n by 2 value. That's updating n equals to n by 2 in equation 1. That becomes your no, that's 7 into P of n by 2 by 2. Let's C into n by 2 whole square. And substitute n equals to n by 4 in equation 1. Then we will get n by 2 value, n by 4 value, sorry. 7 into P of n by 4 by 2. Let's see to n by 4. Okay. And this is equation 2, for example. No, no. First, case, to substitute equation to be so what is the equation? It represents P of n. is equal to 7. 7 into E of n by 2 by. We've already calculated E of n by 2 is 7 into E of n by 4 plus E n by 4 plus this n. Right. So this is equal to 7 square E of n by 4 plus 7 n square by 4 plus Cn square. This is equation number 4. Now substitute equation P 4. Why it is 3 4? What is 7 by 4? We don't know. Divide and conquer itself because we will stop. So from this 4, P of n is equals to 7 square is P of n by 4 value. P of n by 4 is divided over here. 7 into P of n by 8 plus P into square by square by 4 by 4 square by 4 square. This is only this 7 plus 7 C and square by 4 plus P and square. This is equals to 7 for 3 P of by 8 plus 7 square C and square by 4 square plus P square by 4 plus C and square. This 7 for 3 1 by 8 plus let take 7 square C square power. This 1 by 4 square. This is 7 there this 7 by 4 only. This is 1. Eight of the right 4 3. This 3 and right here 5 4 3. This look at right 7 4 8 here power 2 power 8 this C and square 1 by 4 2 minus 1 1 by 4 power 3 minus 2 plus and so on. Right. Here, maybe after here within this bracket, these brackets. For example, 7 by 1, let's say x square, x for 1, x for 3. 1. Right. Same thing as written. Here, what is here? It is 3. 7 by 8, 10 by 7 by 8 plus here is 3. 7 by 4, k minus 1. 3 minus 2, k minus 2. Next one, k minus 1, k minus 3, k minus, and so on. So k minus 1, k minus 2, k minus 3, k minus 4, and k minus k. That is power 0, it will be 1. Right? So that is equals to from this 7 power k into is n by 2 power k plus Cn square. The general mathematics formula n n power any sequence of n numbers. Generally, k minus 1 x power 4, x power 3, x power 2, x power 1 plus x power 4 plus x power 3 plus x power 2 plus x power 1 plus x power 0 is equal to, we'll write x power k. So that is, we'll write k terms. This is equals to 7 by 4 whole power k and t. 7 by 4 whole power k within the bracket. But terms are n natural numbers like n natural numbers, k natural numbers, k terms. This okay, yeah, by n square, 7k 4k. 7 power k plus n square 145 4 power. As we know, n is equals to 2 power k. Apply work on this. Power of n is equals to k into log 2 base 2. That is log of n is equals to n is equals to k to the base 2. Okay. So this equals to log n is equal to 7 power k. K is log base log n base 2 plus k is 100 n square. Right. This is 7 by 4. What is k? 7 power log k is equals to log log n base 4 power log n base. And this is equals to 7 power log n base 2. Let's see. Let's wait. Second line, n power log 7 base 2. Since log of a base b to the power c is equals to b, right? Log a to the base or a power a power log c base a power a power log c base b is equals to a power log c base b is equals to c power log a base c. C power log a base b. And so you can write n power log 4 is also you can write n power log 7 base plus c n square. This divided by this is n square. This is n power log is equal to n power log 2 power 2 is equal to n power log 2 power 2. We can write 2 into log 2 is that is equal to n power 2 into 1. This you can write in square. So that's what this is. And this one you have n is equal to n power log 7 is plus c to n power log 7 base. Log 7 base 1 plus c. You have n. 1 plus c into n power log 7 base. N power log 7 base. That is the order of n power log 7 base is value 2.34. This procedure to derive time complexity of passive hybrid transmission most important. Then for the next unit, third unit, grading method. Third unit, you are calling grading method. So grading method is a one more approach to write an algorithm or to write a solution for the given problem statement. So grading approach says that to the problem it is not able to divide into subproblems. First, in the type of problems, there is a process, there is a solution exists, there is a procedure exists. For greedy approach, the greedy approach says that this is a one solution which can be applicable of time to find optimal solution. You want to find an optimal solution, then you go with the greedy approach. Optimal means optimal value. Optimal and this is what is meaning optimal entity. Optimization. Optimal value means that the given proper state. For the proper statement, The greedy approach are greedy are the planning to take away some items from this. You want to take out some items from this. So generally, before going to identify an item, so before going to take an item, so which item will you prefer? What is the criteria for it? There is various kind of the kind of items are there, panel lights, hats are there, lights are there, speakers are there. There is a mouse is there, mouse speaker is there, for example, and there is a laptop is there, there is a screen is there, chairs and tables are also there. So usually you select an item, screen, because why we go for that screen? So we have decided, anyway we decided to take away some items from this, but simply we cannot control the chairs. If you have chosen an item chair, somebody is chosen a laptop, somebody is with a screen, right? So obviously, for all after completion of your task, after let out of this room, the employee is done, they definitely get the place profit. Who is taken away from the chair? Take away chair from the school. Okay, chair system of the perfect. Screen system of the 4,000. So if intention is to take away. Everyone intention is to take away. But the strategy is following that whatever that is more costly, you can take out. But why is AC is more costly? This AC is more costly. Then we have to go for this item. But we didn't select the item to take away from this book at AC. AC. Because to take out this cost is more related to the choose this item, the more cost item, but this is very high. There is a rising factor. Anyway, we get a maximum profit. But this fact also more. We are unable to disable this. So the various factors are. So we said the optimal value is the maximum profit only. Such that targets are constrained. Maximum profit రావాలి ఈజీగా క్యారీ చేయాలి. అందుకే కదా మైండ్లోకి ప్రాబ్లం ఏంటంటే దీనికి వచ్చినప్పుడు ఏమో మీ ఇంట్లో సోఫా కాస్ట్ సోఫా గ్లాస్ in the hall itself one big screen home theater everything is there in the large plasma TV is there. Unfortunately in your wardrobe there is a 5 plus gold ornament is there. 5 plus gold ornament. All the same cost of big screen is there. And which one we prefer? A 5 plus gold is for easy but ఇంట్లో పెద్ద గవర్నమెంట్ పారామీటర్స్ మోడల్ కదా ఈజ్ టు ప్లాన్ get the maximum profit. రెండు సేమ్ profit carry this. Otherwise, it is more cost compared to this for the gold. Even though we prefer gold only. Even though we prefer gold only. And also one more condition, there are 3 kgs of gold, 10 kgs of silver items there. We found that 10 kg worth of silver and 3 kg of gold. Or 50 kg of silver, 3 kg of gold. And this capacity to carry, that is, you can have a capacity to hold only not more than 3 kg. Not more than 3 kg. So definitely we choose that gold. If it is reverse, 3 kg of silver, 10 kg of gold. 3 kg of silver and 10 kg of gold. He is able to carry up to 3 kg. His bag capacity is to hold only 3 kg. Not more than 3 kg, he is unable to carry. But there is an item 10 kg of other items, ornaments are there. Okay, 3 kg of silver is the gold. 3 kg of silver instead of carrying 3 kg of silver, has to pay among 10 kg, 3 kg of gold is the gold. Why carrying 3 kg of silver is really available? The constraint is that maximum performance of the following. And in the same he has to ensure that how much of capacity ready also can be make sure that. Same thing. ఇంట్లో ఉన్న సోఫా కాస్ట్ సోఫా తీసుకోవాలంటే ఈ డోర్ ఓపెన్ చేయాలి అంత ఓపెన్ చేయాలి అండ్ క్యారీ చేయాలి మళ్ళీ బయట కట్ చేసుకోవాలి అదే 5 class of gold can carry with pocket and you can escape from easy. So there is a condition that maximum profit is easy to escape. Instead of carrying costly plasma TV of 100 TVs. Okay. So that is constraints to get an operation. So here the greedy approach says that it gives the solution for the problem statement. The solution is instead of providing this final solution, it provided one solution as optimal solution. The optimal is that here you want to carry or this as of from discussed example, the intention is to get the maximum. And if you want to reach from one station to other station, want to reach Kakinada, then there are different paths are exist, different routes are exist. In such a case, divide factor is not able to apply. Then optimal solution will be provided by the method called as greedy approach is there. What greedy approach is that? To tell me the problem, I will provide a optimal solution. Best solution I will provide. What is the best solution here? My problem is to reach from Kakinada. Then I am asking to what is the best route? Best route is provided by considering the shortest path. Shortest path. That is minimum distance path we provide. The distance the optimal solution minimum distance. Whereas the previous is maximum problem. There it is produced maximum value, where it is produced here minimum value. So that's what optimal solution a greedy approach will produce a result and give the solution as the best solution. Best may be maximum, best may be minimum. That maximum minimum value best, we can say, depends on the problem statement. The problem is to get titles, maximum profit. Problem is to get finding a route is a minimum distance. So such type of can be identified. Such type of problems can be identified, and we are unable to apply a greedy approach. Then we'll move on to the technique called as greedy method. Right? So in the greedy method, right of three for more the same class, huh? Why for that? Thank you. సినిమా పెట్టి సినిమా కాసేపు నిద్ర కూడా బోర్ పెట్టి కాసేపు మాట్లాడుతుంది కావాల్సిన మీరు అంతా అవసరం కదా 24 hours ఇక్కడే ఉంటుందా మనం సినిమా వచ్చినట్టు వెళ్ళిపోతుంది మళ్ళీ రేపు వస్తాం